The Rutherford Experiment is one of the most important experiments in physics. It took place right around the turn of the 20th century, and in that experiment, Rutherford took radioactive alpha particles, they're actually the nucleus of a helium atom, and they were shot at a thin gold foil, and he just observed what is the angle of the scattering. And what he found was every now and then he saw some atoms coming back at him. They were reflected off of the gold foil and came right back at him. He said this was the equivalent of taking an artillery shell and shooting it at a tissue paper and having the artillery shell bounce back. Backscattering is a very complicated thing to have happen, and it was occurring in this case because there's a nucleus in the atom that contains all of the positive charge of an atom. What we have here is an illustration of the principles behind a Rutherford scattering experiment. We have a wine glass that is centered in the center of the table, and we're going to be shooting marbles at it, just like these alpha nuclei are going to be shooting at you. The device that we're launching it from is done in such a way that they'll be launched all in the same direction, and our goal is going to be just to move the launcher back and forth to try and find the correct direction where we'll get backscattering. So Logan can start launching now, and you can see most of the time when you launch, what is going to happen is it pretty much goes straight through. Not always straight, and there's a little bit of a curve, but this is the kind of behavior that you expect to see. But now as we move it, you'll see that eventually we're going to get to angles where it'll start going off in the perpendicular direction, and eventually, if we can get it set up just right, we will see that we can actually observe the backscattering. So there we're getting something that was close to backscattering, and let's see what else happens. So it's really very delicate. This idea of the wine glass, because it's curved, it's actually the same kind of behavior. What's interesting with the atoms is in the atoms, the nucleus is only 1/100,000th the size of the atom itself. So the chance of having that actually hit is really challenging. Oh, that was beautiful.